Episode 2, The Architecture of Understanding. To understand why Alice and Bob construct such different realities from the same data, we need to journey back to how their brains got built in the first place. Picture a newborn's brain. It starts with an almost ridiculous abundance, far more neural connections than it will ever actually need. It's like having a city with every possible street connected to every other street, lavish, overwhelming, and completely impractical. But then, something remarkable happens as that child grows up. Through a process called neural pruning, the brain begins sculpting itself. Every time a neural pathway gets used, when the child pays attention to language, practices walking, learns to recognize faces, that connection grows stronger. Meanwhile, pathways that don't get used gradually weaken and fade away. It's not addition. It's subtraction. The brain becomes uniquely itself not by gaining something new, but by strengthening some connections while letting others wither. For years of experience, this creates something we might call your cognitive frame, the particular shape your brain has taken through a lifetime of use. Think about it this way. Alice and Bob didn't start with different brains. They started with nearly identical neural architecture. But Alice's frame got shaped by her particular journey, the problems she learned to solve, the patterns she practiced recognizing, the skills she developed, the experiences that marked her, both the successes that taught her what to look for and the failures that showed her what to avoid. Bob's frame formed through his different path, different mentors, different challenges, different moments that taught him what matters and what's dangerous. His brain learned to excel at systematic analysis, at spotting operational risks, at building robust systems that won't fail under pressure. Neither frame is better or worse. They're different solutions to the problem of making sense of complexity. Different prediction machines, optimized for different challenges. And here's where the numbers become fascinating. When scientists map human genetics, they find that any two people share roughly 99.9% identical DNA. Pick two individuals at random from anywhere in the world, Manhattan and rural Tanzania, Iceland and rural Cambodia, and the similarities vastly outweigh the differences. We have essentially the same brain architecture, the same capacity for language, the same emotional repertoire, the same fundamental ways of learning and remembering. This shared 99.9% is what makes communication possible at all. It's why Alice and Bob can sit in the same room, look at the same spreadsheet, and both understand what they're seeing. They're both human brains, making human sense of human information, using human cognitive machinery. But that remaining 0.1%, that's where it gets interesting. Because 0.1% might sound trivial, but it represents something profound, the accumulated differences in how their neural pathways got configured. Every choice about what to pay attention to, every skill developed or neglected, every narrative internalized about how the world works, every experience that left its mark on which connections got strengthened and which got pruned away. For Alice and Bob working with quarterly data, this creates a fascinating situation. 99.9% similarity is what allows them to collaborate at all. They're both processing information using similar underlying machinery. They can both read charts, follow logical arguments, understand cause and effect. But the 0.1% difference is what the disagreement is actually about. When Alice looks at that 23% customer acquisition increase, her frame, shaped by her history of identifying market opportunities, her experience with launch windows, her training in competitive dynamics, lights up patterns that suggest urgency. Her brain predicts, this is temporary momentum we need to capture. When Bob sees those same numbers alongside the rising support tickets, his frame, forged through experiences with system failures, his deep understanding of technical debt, his pattern recognition for operational strain, generates a completely different prediction. This is unsustainable growth that will break our infrastructure. They're not disagreeing about facts. They're experiencing different constructions of reality, generated by prediction machines that got optimized for different problems through different histories. And this isn't speculation or theory. Recent neuroscience research has provided startling evidence that this is exactly how human minds work. In 2026, researchers published a study that would fundamentally change how we think about individual differences. They scanned the brains of over 12,000 people, mapped roughly 35,000 neural connections in each person, and discovered something that should make us rethink everything we assume about cognitive ability and team dynamics. What they found would prove that Alice and Bob aren't just interpreting data differently. They're literally using different neural machinery to reach their conclusions. The research evidence the study, published in Nature Human Behavior and led by Dr. Atkinson, began with what neuroscientists had long taken for granted, that for any given mental ability, there's a specific network of brain connections responsible for that ability. the executive function network, the language network, the attention network. The idea was elegant and logical. If you can identify the strongest neural connections associated with a particular behavior, you found the brain basis for that behavior. So the researchers did what neuroscientists typically do. They measured the strength of roughly 35,000 connections in each person's brain, correlated each connection with the cognitive abilities they wanted to predict, and ranked them from strongest to weakest association. Then they kept the top 10%, the connections most strongly linked to performance, and built predictive models from those important connections. The bottom 90% got discarded as noise. But Dr. Atkinson's team decided to try something unusual. Instead of throwing away that bottom 90%, they built separate predictive models from those supposedly unimportant connections. The assumption was obvious. These weaker connections would be much worse at predicting cognitive performance. After all, if they mattered, they would have shown up in the top 10%, right? They weren't worse. The connections that routinely get discarded as noise predicted cognitive performance just as accurately as the supposedly crucial ones. But here's the stunning finding. They implicated entirely different brain networks. Let me show you what this means for Alice and Bob. Imagine they both take a cognitive test requiring executive function, holding information in mind, switching between rules, inhibiting automatic responses. Both score similarly. Both demonstrate competent, roughly average performance. On paper, they look like two instances of the same cognitive ability. But inside their brains, completely different stories are unfolding. Bob's brain fits the conventional model. His executive function runs primarily through the connections that show up as important in typical neuroscience studies, strong coupling between frontal control regions and visual processing areas. The pathways that get written up in textbooks as the executive function network. When Bob tackles a complex problem, he experiences thinking as a kind of systematic, step-by-step coordination. Visual spatial analysis combined with logical sequencing. A predictive model built from those top-ranked connections captures Bob's performance perfectly. Alice scores just as well as Bob, but her brain tells a completely different story. The connections that work beautifully for predicting Bob's performance don't capture Alice's at all. Her executive function runs through a distributed set of connections that individually seemed unimportant, weak correlations that got discarded as noise in standard analysis. But collectively, those connections predict her cognitive performance just as accurately as Bob's more conventional neural signature. This means something profound about how Alice and Bob experience thinking itself. When Alice approaches the same complex business problem, she's not just using a different strategy. She's running a fundamentally different neural process. Her brain might implement executive function as a more intuitive, background monitoring process that integrates information across multiple networks simultaneously. When they sit down to analyze quarterly data, they're not just bringing different perspectives. They're literally using different cognitive machinery to generate their insights. Now imagine Alice and Bob trying to explain their reasoning to each other. Bob might describe his analytical process in terms of systematic evaluation. First, I looked at the acquisition trends. Then I cross-referenced with capacity metrics. Then I projected forward based on historical patterns. Alice might struggle to articulate her equally valid process. I just see the whole pattern. The numbers feel like they're pointing toward a narrow window of opportunity that we're going to miss if we don't move quickly. Neither description captures what's actually happening in the other person's brain. Bob's systematic approach isn't just a personality preference, it's how his neural networks are actually implementing complex reasoning. Alice's intuitive pattern recognition isn't fuzzy thinking, it's a different but equally sophisticated cognitive process. And this reveals something crucial about team disagreements. What we typically interpret as Alice being impulsive or Bob being overcautious might actually be two high-performing cognitive systems operating through different neural architectures, each optimized for different types of pattern recognition. The disagreement isn't about competence. It's about cognitive diversity in action. But if this is true, if smart people can reach different conclusions not because one is wrong, but because they're running different neural processes, then everything we think we know about handling team disagreements needs to change. The question is no longer who's right. The question becomes, how do we access both cognitive systems? How do we have conversations that leverage these differences instead of fighting them? Because it turns out there are specific ways to do exactly that.